Static electricity. Hundreds of years ago, that was the first observation of an object becoming charged. It appeared as a spark. Throughout time, man-made electricity evolved and flourished, from the invention of the battery to the development of the first electrical circuit. This now brings us to two different types of fundamental electrical circuits, series and parallel. The series and parallel circuits differ depending on how a circuit is constructed, which further affects the effects of their uses. Both shall be explained in detail. In a series circuit, there is only one singular electrical line. Upon this electrical line, all components of the circuit reside here. This includes your classic stuff such as LED bulbs, resistors, capacitors, etc. But due to the nature of a series circuit, no component can be removed and form empty space. Otherwise, there is no full circuit anymore. Your LEDs won't light up. Your resistors won't resist anything as the current won't flow anywhere. That fault becomes one of the series circuit's main disadvantages. In a parallel circuit, there can be as many electrical lines as one wants, and with each electrical line voltage will remain the same consistent value. Each bulb on each electrical line will flash just as bright as the last. The same cannot be said about the series circuit, which will be mentioned later. As for removing an electrical component from any part of a parallel circuit, that electrical line will be rendered dead. But as for the rest of the electrical lines, they work just fine, as if no difference was made at all. As mentioned, there are a number of differences between these two types of circuits. One not explained completely yet is the voltage differences between both. As stated earlier, the parallel circuit contains the same amount of voltage throughout each electrical line. This is not the same with a series circuit. Say there are 3 bulbs in a series circuit, connected in the same line. The first bulb will shine bright, but the second bulb will appear more faded, leaving the last to barely shine at all. In real-life examples, this is why a lighting system in, for example, houses and properties are constructed in a parallel circuit, so that each bulb is the same consistent brightness. When only talking about the components of Ohm's law, voltage, current, and resistance, it's very easy to calculate with these simple formulas. For a series circuit, to find the resistance. It's just all the resistance values added together. This is the same for the voltage as well. For the current, which is most commonly the unknown value, taking from Ohm's law, it is the total voltage over the total resistance. For a parallel circuit, voltage remains the same value throughout the entire circuit as previously stated. Total resistance in a simple 2 electrical line circuit is ρ x or 2, all divided by ρ or 2. Then finally, to find total current, you have to find each individual current for each electrical line. This means for Ione, you must multiply total voltage by 1 ρ. Same with ITO, but instead with RTU. Once each current value is found, all that's needed left is to add each value to find the total current. That's pretty much it. Easy shit.